In lesson 12.3, experimental probability of compound events, we're really building off of what we did in 12.2. How do you find the experimental probability of a compound event? If you remember in 12.2, we were working on simple events. So we're going to expand this now to what's a compound event. But the process is pretty much the same thing of what we have to do. So here, looking at the definition, a compound event is an event that includes two or more simple elements, such as flipping a coin and rolling a number cube. Okay, there's the and in there, that's important. A compound event can include events that depend on each other or are independent. So it doesn't matter. The key here is or. They depend on each other or are independent. Events are independent if the occurrence of one event does not affect the probability of another event, such as flipping a coin and rolling a number cube. Let's go through this here. We'll talk about it in class too, but what are the possible outcomes of flipping the coin once? And that's you're either going to get heads or you're going to get tails. What are the possible outcomes of rolling a standard number cube once? So you're either going to get the number 1, the number 2, 3, 4, 5, or 6. So then we're going to complete this list. As you can see, we can have a heads 1, a heads 2, 3, and so forth. Tails 1, tails 2, and you can complete this out. And then you go ahead and you count what that is. Okay, so how many do you count here? And then that's what your answer would be. So now they want you to go ahead and they want you to do this exercise, and then we'd fill in this table and we'd answer the question. If we look at experiment 1 here, we're going to calculate the experimental probability of a compound event. They have a food trailer serves chicken and records the order size and sides on their orders as shown in the table. What is the experimental probability that the next order is for 3 pieces with coleslaw? So we're looking at, we have two-piece chicken, 3-piece chicken, and then they can either get green salad with that, a macaroni and cheese, a french fry, or a coleslaw. So as they went through the orders, this is what they came up. There were 33 orders of 2-piece chicken with green salad. There were 65 orders of 3-piece chicken with french fries. So what we're interested in is the probability of 3-piece with coleslaw. Use that number there. But the first thing we have to do is we have to total this up, because if you remember, the probability of an event was the number over the total events. That was from 12.2. So what they do is they go ahead and they total the numbers up here. So they added all of these, and so you get 330. And then you have 55 you chose from there. So find the experimental probability of the 3-piece plus the coleslaw. So right here. Okay, so we're going ahead and put our numbers in place, and we have the 55 over the 330. And then you simplify this as much as you can, and in our case it's going to come down to 1/6. So what that means is that for every 6 orders, one of them is going to be coleslaw with 3 pieces of chicken. Okay, now it doesn't mean it's an absolute guarantee that that's going to be, but there's a high likelihood that at least one of the next 6 orders is going to be for 3 pieces of chicken with coleslaw. So here on the Your Turn, drink sales for an afternoon at the school carnival were recorded in the table. What is the experimental probability that the next drink is a small cola? So if we take a look, we got the small, we got the cocoa here. Okay, so it's going to be 60, and then you have to come up with the total. Okay, I'm going to let you do that. And then, of course, then you have to simplify what your answer is. And if you keep in mind, we're also talking about proportional relationship when we're doing that simplify. 60, what is that equal to when you simplify that down? In 12.2, we're going to look at using a simulation to make a prediction, and it's going to be a compound event this time, and we're going to be looking at a car or truck. So let's maybe read this. At a street intersection, a vehicle is classified either as a car or truck. It can turn left, right, or go straight. About an equal number of cars and trucks go through the intersection and turn in each direction. Use a simulation to find the experimental probability that the next vehicle will be a car that turns to the right. So we're looking for a car that turns to the right, okay? So we're going to choose a model, and what they've done is they've used a coin toss to model the two vehicle types. So they're saying that heads is going to be a car and tails is going to be a truck. And then they're going to use a spinner divided into three equal sections, and they represent the directions. So as you can see that right here, we have left, right, and straight. So now we're doing a compound event. We're going to flip the coin is one, and we're going to spin the spinner is another. So they have listed all our possible outcomes that we can have. We can have a coin with a car going left, a car going right, a car going straight, and then the same for the trucks. So the simulation is conducted. They've done this 50 times. And this is the outcome that they came up with. They came up, when they flipped the coin, remember this is the coin, this is the spinner here, okay? So they have a car turning left 8 times, a truck turning left 9 times, a car turning right 6 times, a truck turning right 11 times, and a car going straight 9 times, and a truck going straight. So now we're looking for what's the probability of a car turning right. So we go down the car, we go here. So that's going to be 6 times. And then they did this 50 times. So 6 over 50. So the probability of a car turning right is going to be 6 times out of 50. And they simplify it again, or that proportional relationship, and it's 3 out of 25. So that's what they would expect here. In the your turn, a jeweler sells necklaces made in 3 sizes and 2 different metals. Use the data from a simulation to find the experimental probability that the next necklace sold is a 20-inch gold necklace. So we're going to be looking under gold, and we're going to be looking under the size, okay? So you could do the same thing up above. You could use a coin because it's 2-sided, and you could use a spinner if you want. You could use any other thing that would give you 3 outcomes or 2 outcomes, but that's just what they happen to use. And then you would go ahead and find that. So a 20-inch gold necklace. So a 20-inch gold necklace. So you're definitely going to have it over 12. You're going to have 12 over whatever your total is here. You can calculate out your total. The rest below are the 2 guided practices for the section. And if you go ahead and accomplish those, if you need any help, let me know and I'll help you out. Have a good day.